at normal distribution, and there's a whole bunch of data here with a bunch of notes, and we just kind of ran it through standard deviation, right? So we're going to take this info. So this was all of the data we had to start. There's 15 points, and we kind of built our standard deviation chart, and we discovered our standard deviation to be 15.2. And our mean, which is really important, was 81.8. So we're going to build a normal distribution curve. So we're going to go on the assumption that this is normally distributed. So kind of have a line down the middle, and that stands for your mean, or a lot of times they call it the x bar. And in our case, it was 81.8, right? And a normal distribution curve, I'm going to do my best to be symmetrical as possible. That wasn't great, but okay. So what it's saying is that the mean is in the middle, and most of the data you'll collect, especially if we were to continuously collect data, it would be really centered around the mean, and then we would only have small amounts that are very far away. And the closer we get, the more data there is, and then same idea, the farther we get, the less data there is, to both ends. Those are the tails, they call them. A normal distribution curve, usually we'll build it to 3 deviations, or 3 standard deviations. So we'll say that this is 1 deviation in the positive direction, 2 deviations in the positive direction, and that's about there, 3 deviations in the positive direction. So I'm just going to write our lines in. It might look a little odd to start. No, this isn't. I think I should space those out. Those aren't very great. Let's do that. That's a little better. These are a little short. Okay. This makes a little more sense in terms of our curve. So when they talk about a standard deviation, they might represent this as x bar plus 1 standard deviation. Okay, this might be represented as x bar plus 2 standard deviations, and this would be represented as x bar plus 3 standard deviations. And they use this mu here to represent it. Same concept here: x bar minus 1 standard deviation, x bar minus 2 standard deviations, and x bar minus 3 standard deviations. Okay, and those are the symbols they use for those words. Our standard deviation, if you notice from above, is 15.2. So this number needs to be 81.8 plus 15.2. Okay, so carry the 1, 100. Is that what we got? I made an error here. That should have been 15.2, not 18.2. Either way, 1 deviation is very, very high in terms, especially because we're talking about, 15.2. We're talking about grades. 5, 6, 7, 97. Okay, so that'd be 1 standard deviation. 2 standard deviations, we have to take this 15.2, multiply it by 2, or we can just add 15.2 from this value here to find out what the next value representing that is. Okay, so let's kind of use our calculator along here. So we started at 81.8 and we added 15.2. So the first number we got was 97. Then we're going to add 15.2 again, 112.2, which is impossible with grades. But we took some sample from your teacher's class, so we're going to use it anyways. And then 3 standard deviations, okay, would be, I guess somebody got a lot of bonuses if they get that, and then plus 15.2, and this is just ridiculous, 127.4. That's fine though, 127.4. We do the opposite to find out the values of a standard deviation the other way. So we had 81.8, subtract 15.2, 66.6, okay, so 66.6. And then we can just take that value, same idea, and subtract again. Minus 15.2. Oops, sorry, I need that number. There we go. 51.4. And then finally, same idea. That number. Oops. Minus that number. 36.2. Okay. Okay, so why did I write these numbers here? What I did here is, and what we're supposed to show, is the mean is the average, right? It's a really high average, especially if we're thinking about grades, 81.8. What it's saying is, of the data we collect, 68, if it's normally distributed, 68% of the data should fall between one deviation. So there's one deviation in the positive direction and one deviation in the negative direction. So 68% of all of our grades should fall within there. Okay, so between 66.6 and 97. Okay, next, let's do green out here. And this includes the yellow, okay? Even though I'm doing it as a different color, this is including the yellow. What this is telling us is that 95% of all the data we collect should fall between these two values. So this is plus 2 deviations, okay? And this would be minus 2 deviations. All of 95% of all data should fall between 51.4 and 112. Yeah, we know nothing's going to go on the upper end of that, okay? And then finally, the very last one there, this is our third. So this includes the yellow and the green, okay? What this is telling us is that, we already did blue, we already did red, let's do green, is that this is 3, and this is positive 3 deviations this way, and negative 3 deviations this way. This is saying that 99.7% of all your data, if it's normally distributed, so that's almost 100%, okay, should fall between 36.2 and 127. Well, we know the 127, and really what it means is there's almost going to be nobody under 36, okay? So that's how we kind of build our normal distribution curve from the info above. What we can do to see how accurate it really is, we can kind of test this by finding our data between 66.6 and 97 and finding out what percentage is really between it. So let's actually do that. I'll highlight in yellow. What is between 66 and 97? Okay, 70 is. Now, that's 97 on the dot.
Yeah.
And that was 97 on the dot. We're going to include it, okay? That's lower. That's in the range, higher, in the range, lower, in the range, higher, in the range. Was that right?
I
think so. What were we? Between 66 and 97? Below, higher, below, higher. Great. So we just counted, well, we can just subtract. There was 15 minus 1, 2, 3, 4, 11. Okay, so let's find out. Of the data we had, 11 out of our total 15 were in this first range. So as a percentage, and the more data you collect, assuming it's normally distributed, the closer you should be to these percentages. 73, so a little higher, 0.3. Okay, so we got about 73.3% of all our data fell between those. So that's a little higher, okay? And probably the more data we get, the smaller our standard deviation would be, and probably close it in a little. And then between 51 and 112, oh wait, it's 51 point something, isn't it? 0.4. Ah, okay, this guy actually doesn't fall in it because he's below 51.4, but he does, he or she, whatever it is. And there's only one, so that's 14 out of 15. What color was that? That was blue, right? 14 out of 15 fell in our other range, which is as a percentage, 14 out of 15, 93.3. Oh, and you can see that's really close to our 95%. It's a little off, right? But it's relatively close. And then finally, within 3 deviations, all of our data, our 51 was definitely higher than that. So 100% of our data fell within 3, and usually that number is supposed to be about 99.7, right? So we're pretty close to a normal distribution here. That should have been 95, and this one should have been 68. Okay, so not bad. And the more data we get, we would assume that the closer we get to a normal distribution.